Hello everyone, I am Dr. Balkrishna Kanpar. I am teaching physics in Government College Jean. Today I am going to discuss here nucleus size by Rutherford Scattering Experiment. Here we are going to decide how the size of nucleus is measured with the help of Rutherford Scattering Experiment. This topic comes under Unit 1st of Nuclear Physics in B.Sc 5th semester. As this is our discussion about the nucleus size of Rutherford Scattering Experiment. How we are measuring the size of nucleus that will decided with the help of Rutherford Scattering Experiment. Uh, in the alpha particle scattering experiment, Geiger and Marsden in 1909 allowed fast moving alpha particle from the radon source on a thin metallic gold foil and studied the angular distribution of scattering alpha particles. To avoid the absorption of alpha particle by air, the apparatus is placed in the vacuum chamber. Here, this is a diagram which is showing the Rutherford scattering experiment. Here, a radon source is used, which is basically scattering the alpha particle, and this radon source is kept under the lead block. This slit is used in front of this radon source, and after this, the alpha particles which are coming from the radon source, they are passes through the gold foil, and in this gold foil there may be the scattering that can be detected through any detector. Here some observations were made in this alpha particle scattering experiment of Rutherford. First observation, that is, most of alpha particle pass through the gold foil without scattering or scattered through small angles. It means the foil have most of space empty. Second observation, that we are seeing a very few alpha particles were scattered through angle greater than 90 degree. Some even in backward direction also. Rutherford fails to explain the Thomson model, that is, atom is positively charged sphere embedded negatively charged electrons. A collision between alpha particle and electron cannot show such large angle scattering. This can be shown with the expression MD that is equal to or approximately equal to 7344 ME. Rutherford explained this large angle scattering by assuming the positive charged particles were repelled by massive positive charge concentrated in a small region of space called nucleus, which is surrounded by a cloud of electrons. So in this way, these observation is basically showing some space which is called the nucleus, and this nucleus is basically surrounded by electron. So in this way, according to Rutherford, the alpha particles of given kinetic energy half mv square come closer to nucleus till they feel Coulombic force of repulsion. It is important to know that they are feeling these particles are feeling Coulombic force when they are coming near to the nucleus at a certain distance d. As in this diagram, the distance d is indicated as certain distance d, the nucleus come to the rest momentarily and then turn back. The energy at this point is Coulombic potential energy. The distance d provide rough estimation of nuclear size called distance of closest approach. In this way, we can explain that the d, which is showing the estimation or that is a rough estimation of nuclear size. So if we want to find out the value of D, and D is basically the size of nucleus, rough estimation for this, and for this we are going to calculate as at distance of closest approach. We can write half mv square, that is kinetic energy, that may be equal to Z into E into Z into E, where Z is atomic number, E is electron, divided by 4 pi epsilon 0 D. In 4 pi epsilon 0, this is a constant. D again we have discussed that D is the rough estimation of nucleus size, and this D may be calculated as D is equal to 1 by 4 pi epsilon 0 into 2ze square divided by 1 half mv square. If we are taking in case, this is case for a gold foil, and suppose the atomic number of gold foil, that Z is equal to 79, and in place of Z if we are going to put here 79, then what will be the value of D? So we will write D is equal to 9 into 10 to the power 9. This is the value of 4 pi epsilon 0 into 2 Z is 79, the charge on electron 1.6 into 10 to the power minus 19, and it will be squared divided by 5.5 into 1.6 into 10 to the power minus 13. So the value will be approximately 4.15 into 10 to the power minus 14 meter. So in this way we are saying, by increasing the velocity of kinetic energy of alpha particle, one could go off to minimum distance, that D is equal to 4.15 into 10 to the power minus 14 meter for gold. This the size of radius nuclear size for gold, if we are taking the atomic number, that's 79. Similarly we are taking another example of copper foil, and here Z is equal to 29. So keeping the value in 29 in place of Z in similar formula, so D is equal to 9 into 10 to the power 9 into 2 into 29 into 1.6 into minus 10 to the power minus 19 whole square divided by 5.5 into 1.6 into 10 to the power minus 13. That is approximately is equal to 1.51 into 10 to the power minus 14 meter. Thus the value of D is larger or increase with atomic number of target. As we are increasing atomic number, the value that will be more value we will be get that nucleus size. The Rutherford famous planetary motion may be understood with following examples. Here we are comparing a hydrogen atom as a radius of its nucleus and the atomic size. What difference will be in atomic size and the nucleus, that we are going to calculate with this example, as we know the size of nucleus as according Rutherford model less than 10 to the power minus 14 meter. If we look at hydrogen atom, the radius of its nucleus is 0.8 femtometer. It means it can be written 0.8 into 10 to the power minus 15 meter. Now size of uranium nucleus is 7 femtometer, that may be written as 7 into 10 to the power minus 15 meter. Similarly, if we are comparing this with the size of atom of hydrogen, the size of hydrogen atom, that is 0.5 angstrom, and it can be converted in femtometer as approximately 50,000 femtometer. Now if we are comparing the sizes of hydrogen atom and hydrogen nucleus size, radius of hydrogen nucleus, as we have earlier discussed, 0.8 femtometer, and the size of hydrogen atom is 50,000 femtometer. So the ratio may be 50,000 divided by 0.8, and that is approximately the value of this will be 62,500. So we are saying that in this way, by comparing the hydrogen atom with its nucleus, that hydrogen atom is 62,500 times larger than its nucleus. So it is very large comparatively. The atom size is very large comparatively to the nucleus of hydrogen. So this is the topic about the nucleus size of Rutherford Scattering Experiment. We have discussed, and here after at last we have also compared the atomic size with the nucleus size. Thank you.